If you look at the video that we did yesterday here, we were dealing with questions that only had a multiplication. Not inside the reduction, I'm not talking about inside the reduction, but if you look at your term, say you're dealing with one thing here, hence it was simple for us to say this one and this one, they're going to divide each other, because basically we're dealing with one term. So if you look at what we're going to be doing today, we start to look at questions whereby you have a minus in between. You can have a minus in between, or you can have a plus. So this part here, it's like you are dealing with one term. We can highlight this and say this thing here, it represents one term, this whole thing here. And then we can say then this is another term here. Now, once you see plus, minus, you should keep it in mind that you're supposed to factorize, supposed to use identities. Now, nothing has changed. When we go to our Cartesian plane, we can then say, okay, we have the following people which are reducing again. So the only thing that they can do, these people, is that they can reduce. So this one they can reduce. And then if we look at the vertical line, the following people, they can reduce, and then they are going to change. Not only do they reduce, but they change again. So the first thing that we do is to go and check each and every one of them to check whether they have a reducing angle which can reduce only or reduce and change. So if we go to 180, as you can see, our 180 can only reduce. Okay? So we'll have something like this. We'll have the 10 of x. So I'm going to write it as an acute angle. And then it says multiply by, if we look at 90 here, what does 90 do? It reduces and then it changes. So here we're going to have cos instead of sine. So we'll have cos x. And then this is going to be all over. If we look at this one here, we have 90. What does 90 do? It changes and then it also reduces. So here you're going to have the sine of x. And then it says minus after it. Go to 180. What should we say about 180?
It only reduces.
It only reduces. So we will have
Cos x.
cos x all over. Then we have it changes again.
Yes.
It reduces and changes. So we're going to have
X.
we're going to have the cos of x. Okay, the next thing is to go and check whether we are going to have a positive answer or a negative answer. So if we say the 10 of 180 degrees, and then instead of x, we just put 1. And then it gives us what? A positive answer. So it means this thing here is supposed to be positive. We leave it like that. And then we go to the next one. It says here sine 90 degrees minus 1. It gives us a positive also. So we leave it like this. And then we go to the denominator. It says we have cos 90 degrees minus 1. Gives us a positive again. Then we go and check this one. We have cos 180 degrees minus 1. Gives us what? Negative. So we'll come and put our negative inside here. Let's set it. So we'll put negative here. And then the last one that we have, it says we have sine 90 degrees plus 1. It's one positive also. So here we only have one negative. This thing here is negative. Okay, and then from here onwards, what we are supposed to do then is to say, okay, here we have a positive and a positive. So this whole thing here, it says we have positive multiplied by positive, meaning that it's going to be positive. So this one here, we're going to leave it like that. We'll have the tan of x multiplied by the cos of x, all over the sine of x. Okay, here we have negative multiplied by positive here. Okay? Now, what is negative multiplied by positive? Negative, but you still have this negative outside. Can you see that? Okay? So I would say negative multiplied by negative. What is negative multiplied by negative? So it means this thing here is going to be plus. This one is going to divide this one. And then what am I supposed to have here? I'm supposed to have 1. But you get, how do you get positive? So we have a negative multiplied by negative, which is going to give us what? A positive. Now, nothing has changed, guys. If we find ourselves in this way, and then we still want to reduce this a little bit further, what we can do here is that we can change this 10 here. We know how to change 10. Okay? So what happens if we change this 10 here? What we're going to have is the following. Look at this. I want to write it so that you can see that this 10 has its own numerator and its own denominator. Okay? So I'm going to have this top part as my numerator, and then I'm going to have this one as my denominator. Now I'm going to use the division line that we spoke about. Okay? of alien rate. So I'm going to write this thing as the sine of x all over the cos of x multiplied by this cos x here. This cos x here is on the numerator, so I'm going to have cos x there. Now, if they didn't write anything here, it means which is the 1 here. Okay, now I'm going to change this thing here. It's a division line. Okay? If it's a division line, I'm going to use the division line that we're using in primary. Then it says which this is going to be divided by the sine of x. Plus, there's still a 1 here. Now, how do we change the division line? We know how to change the division line. Okay? This thing here is all over 1. So if we are going to change this division line into a multiplication, then what's going to happen is this. Change this to a multiplication. It says this one goes up, this one goes down. Okay? And then what we're going to have then is this. We're supposed to have 1 all over the sine. Okay. And then from here onwards, you can come and say, okay, this one and this one, there's a multiplication between, so it means it's 1 term. Then you can say, here there's also 1 term. This one multiplied by this one. So basically, if you say this one multiplied by this one, it's supposed to give us cos x multiplied by the sine of x. It doesn't matter which one I start with. I did it on purpose, it's not a mistake. I'm just emphasizing the fact that you can start with cos, you can start with sine, since you're multiplying. Now, let's also do that. Let's also multiply it with whatever is outside, because when we multiply numerator and numerator, denominator and what and denominator. So if I multiply with 1, this is what I'm supposed to have. After that, I will have cos multiplied by 1 multiplied by sine. Can you see that? So what is going to be that? It gives us cos x multiplied by sine x. And then it says we still have plus 1. Now from here, you can clearly see that this one is going to divide this one again. And then this one is going to divide this one. What are we left with then? We are left with 1. So you have 1 plus 1. What is 1 plus 1? 1 plus 1 is 2. Then it means which our final answer here is going to be equal to what? To 2. So guys, we should be careful when we're dealing with the plus there. Let's look at the following as an activity now. We are going to take number 5 and number 2. We're taking number 2 and number 5.